that's how we find the roots. All right. So S equals -2 plus or minus square root of 2 squared minus 4 times A times C all over 2. So that's -1 plus or minus the square root of -16 over 2. So it's -1 plus square root of -1 times square root of 16 over 2, or -1 plus the square root of -1 square root of 16, let's say minus over 2. So that's -1 plus J2, or -1 minus J2. Okay. Okay. So the roots of this we could factorize it if we want, but we don't need to factorize it. This is what we did last class. We showed how we could handle Laplace transforms of this form. I just want to point out to you that the roots are complex conjugates. Although I didn't say that to you last class, that must be true. Roots are complex conjugates. Okay. Now, I want to show you a different way. I want to show you a different way that'll come in handy for more complicated equations. So to rewrite, we have f of s equals s plus 5 over s squared plus 2s. Of course, this is the quadratic. Okay. And q of s, I'm going to find something called q of s. Q of s is everything other than the quadratic. So in this case, q of s equals s plus 5. S plus 5. So if you like, q of s is f of s divided by the quadratic. Sorry, I mean multiplied. So q of s is everything except q of s is f of s. Everything of f of s except the quadratic. Now, here's what we do. We evaluate q of s at s equals -1 plus j2. And what do we notice about that? This is the root. This is the root of the quadratic. So we say this is q of -1 plus j2, which is -1 plus j2 plus 5. That's just substituting this into s. And that, of course, is 4 plus J2. And what's the magnitude of 4 plus J2? What's the magnitude of 4 plus J2? Folks, what's the magnitude of 4 plus J2?
Is it the square root of 2?
Where you get that from, Mr. Buchamp? Where you get that from? What did you do to get that answer? You should have done this way back in the
Yeah, I remember you teaching us something like this, the complex numbers.
T120 and also mathematics. Folks, you gotta know. Let's draw 4 plus J2. What does 4 plus J2 look like? Well, there's 4, and there's J2. So where's that number? That's 2. That's 2 on the imaginary line. And that's 4. Okay.
Dr. Carter, they can't see your screen. I mean, I can't see you too, right?
Graduate, the screen cut out.
We did see J2 and 235. But yeah.
Graduate, the screen cut out.
Okay. I think it dropped. All right. Can you see it now?
Yes, sir.
Okay. All right. So here's a plot of 4 plus J2. This is the J-axis. This is a real number axis. This is the imaginary number axis. 4 plus J2 is right here. I'm asking you, what's this length? That's what I'm asking you. What is this length? That's what we mean by magnitude of a complex number.
That should be
What's that
square root of
length?
6. No,
Square root of what?
No, sorry.
What is this length?
2 square root of 5.
Is that a square root of 20?
4 point.
It's Pythagoras.
Yeah.
It's Pythagoras. And you folks are pathetic. And what is this angle? What is that angle? What is theta? What is theta?
(26.57 degrees).
Tan theta equals opposite over adjacent, 2/4. So theta equals inverse tan of 0.5, which is 26.57. Okay. So the 4 plus J2 then, 4 plus J2 is square root 20 at angle 26.57. And we call this M theta. We call this M theta. All right. And there's something else I wanted to find for you. Let's go back to the root of the quadratic, the root of the quadratic. This is S equals negative alpha plus J omega. Okay? So clearly then alpha is 1 and omega is 2. Okay. So f of t will be m over omega e to the minus alpha t sine omega t plus theta, where this theta is that theta, this m is that m, this omega is that omega, this alpha is that alpha.
Is that omega plus theta? Yeah, all right.
Omega t plus theta. Don't you see that this is a t?
I didn't look good enough. I see it now.
So in our case then, this is the square root of 20 over 2. E to the minus alpha, alpha is 1. Okay. Sine omega, omega is 2. 2t plus 26.57 degrees. Okay. I'm going to rewrite this because it's all jumbled. It is all jumbled up. I'm going to rewrite it.
Dr. Cartwright, for this formula here, we always can be using this if we encounter a question like this, or would it be like a question will come up? It'll always be the same formula, right?
The formula will be the same. Yes, you need to memorize this formula.
All right.
Which part are you going to rewrite? The bottom part?
Let me go. Yeah, I'm going to rewrite it. Okay. So, f of s is s plus 5 over s squared plus 2s plus 5. So the first thing we need to know, s squared plus 2s plus 5 has complex roots. That's the first thing we need to know. To use this method, we need to know this quadratic has complex roots. And the roots, of course, are s equals negative 1 plus j2 and s equals negative 1 minus j2. And what we care about is this one. We care about this with a positive j. So this is negative alpha plus j omega. So clearly then alpha is 1 and omega is 2. 2 radians per second.
Dr. Cartwright, one more question. Why would you choose the positive over the negative? Is it mandatory?
Because that's the method. That is the method.
Oh, so
I am teaching you a method. I am simply asking you to learn the method.
Okay. So we always go for positive.
Exactly.
All right.
I am not trying to prove the method to you. I'm simply giving you the method. All right. So to use this method, the quadratic has to have complex roots. And I could say complex conjugate roots. Because that's going to be true. So this is case 3 then. This is case 3. So once we can find Q of S, and Q of S is everything except the quadratic, so that's S plus 5. And then we evaluate Q of S at S equals -1 plus J2. And when we do that, we find out that is in fact the square root of 20 at 26.57. And then we use the formula F of T equals M over omega e minus alpha T sine omega T plus theta, where this is M, this is theta. So this is square root 20 over 2, sorry. E minus T sine 2T plus 26.57. And of course, we could evaluate this. So this would be 2.236. Okay. Any further questions concerning the method? Okay, let me let you do one example and then I'm going to move on. Because I sent you last year's final exam, and as you can see, we still got a lot more work to do.
Other guy, you repeat what you said just now, the last thing you said about the final exam.
So that means
I sent you the final exam for last year.
Oh.
So Dr.
I'm sorry, the last person to talk, I didn't hear you at all. Please start again.
That was me. So that means
I didn't hear what you said.
Covering chapter. That means you'll be covering chapter 3 through probably 7 for the final exam.
No, more than that.
The midterm.
More than that.
You're gonna include the midterm too before the midterm on the final exam.
It's mostly after what we did after midterm.
Okay.
And I have to cover as well. So we only got what? About 3.5 weeks. We got a lot of work to do. And right now, I'm laying the foundation for the work we have to do with Laplace transforms. All I'm doing right now is giving you the basics of Laplace transforms. We can see how we use Laplace transforms. So okay. Okay. So go ahead and find the roots of the quadratic for me. Find the roots of the quadratic for me. Send me answers in the chat.
Or we gotta find it for the both of them at the bottom.
Excuse me?
We have to find it for two of these.
Yo, man, that's the same quadratic.
Okay.
That's what this equal signs mean.
Oh, I thought that was a minus, right? But
Is that a 6 in front of the F's for the second equation?
Mr. Johnson, please work out that first quadratic and tell me, answer your own question. What's s plus 3 squared? S squared plus 6s plus 9. Please send me the roots in chat. That's right, Miss Buchamp, but why you send it to everybody? All right. So the roots are negative 3 plus J2 and negative 3 minus J2. And everybody should be able to do that. And that was last lesson. So I'm not going over that again.
Yeah, we're supposed to use the formula to get that right.
So excuse me? The quadratic formula, yes.
Formula to get that right. Yeah. Okay.
Yes.
Yeah, I heard you.
Okay, so, well, actually, the truth is, you can use this to get that. That's the truth. But we ain't going there. Use the formula. So clearly, then, alpha omega is 2. What's step 2? What's step 2?
Finding a magnitude and angle.
And how do we do that?
You gotta use the positive root, negative 3 plus J.
We ain't there yet. You're not telling me a step you need to do before you do that.
Oh, my bad.
You could start off by drawing it on the plane.
Absolutely not. Absolutely not. I don't need the magnitude and phase of this. I don't need the magnitude and phase. I don't need the magnitude and phase of the root. What do I need the magnitude and phase of? Folks, just reread the notes you just took.
You need the magnitude and phase for S.
No, I just told you that. This is S.
In the example, you started off.
What do I need the magnitude and phase of?
Quadratic.
Then you have to put in the negative 3 in it.
Wow. Y'all don't pay attention. See right here? Just the previous page. See right here? We get the roots of quadratic. There's the roots of the quadratic. So we identify alpha, we identify omega. What's the second step? We find Q of S. That's the second step. And what did I say Q of S is?
That's when you say Q of S is F of S multiplied by the quadratic.
Q of S is everything except the quadratic. So in this case, what is Q of S?
That's S minus 3.
S minus 3. And then what?
And we don't know what S was. S was the start.
And then what?
All you do is minus 3 from the root.
Miss Buchamp, I'm not hearing you. Please say again.
I'm saying we don't find S. S is this root here. So we just go minus 3 from this root.
We evaluate Q of S. We evaluate. That's what that line means. You don't need to learn the language to math. That line means evaluated at. I'm trying to
yeah, that part that confused me for real.
evaluate at what? At x equals what? X equals this root. Not root. X equals -3 plus j2. So what does that mean? Where you have x, you replace it with this. So that is -3 plus j2, -3 equals -6 plus j2. Now we find the magnitude of this. This is what we find the magnitude of. What's the magnitude of -j plus -6 plus j2? What's the magnitude of that?
That's the same square root of 20.
Square root 20.
I get 2 square root of 10.
In other words, square root of 40. This is square root of 40. And again, it's Pythagoras. Plot it. This 2 is -6. So it's this length, and this angle. So this side here is 2 long, and this side here is 6 long. So by Pythagoras, this is the square root of 40. This is the square root of 40. Square root of 36 plus 4. I mean, how do y'all get through 120? Now here comes the fun part. What's the angle equal to?
Would that be inverse cosine 2/6?
Yo, man, you don't know high school trigonometry?
Not cosine, my bad. Tangent, inverse tangent. 2/6.
What you just gave me is this angle here. What you just gave me is this angle here. Theta 1. That's what you just gave me. I don't want theta 1. Yes, tan theta 1. Tan theta 1 is 2/6. So theta 1 equals inverse tan of a third. Theta 1 equals.
You could just subtract 180 from that angle you get and get the angle you want.
Thank you very much. So 18.43 degrees. So theta, the angle we want is theta, this angle here. And clearly that angle is 180 minus theta 1. 180 minus 18.43. $161.6 degrees. 161.6 degrees. So there's M and there's theta. Now what? Now what?
Now you can substitute the answers you get into the formula.
Okay.
Dr. Gadrick, a quick question about that angle.
Yes.
Why we had to look for that one specific?
Yes.
Why we had to look for that one specifically, and not the angle within the triangle?
Because angles are measured with respect to the positive x-axis.
Oh, Okay.
Again, this is Mathematics 7 and Mathematics 8. It is also ELT 120. Angles are measured with respect to the positive x-axis. Not only that, since this is negative and that's positive, we're in the second quadrant. We are in the second quadrant. Second quadrant means your answer is going to be between 90 degrees and 180 degrees. First quadrant, second quadrant, third quadrant, fourth quadrant. By the way, if you would have put this in your calculator and you would have put inverse tan of 2 over negative 6, you will not get this angle. You will get the fourth quadrant angle. So your calculator would lead you astray. That's why you need always to plot your complex number so you can tell what quadrant it's in. And again, this is something you should have learned in 167 and 168. So give me the formula.
The formula is magnitude over.
No. Give me the equation.
F. Let me see if that's still F. That's G of T.
Yes, G of T equals
Magnitude over. What's the name again?
Mr. Buchamp, you were saying something?
Yeah, I forget this W mean. It's magnitude over
Omega.
omega. No, not just omega.
Yeah.
What's the magnitude? What's omega?
The magnitude was the square root of 40.
What's omega?
The omega was 2.
Okay, what's next?
E to the negative T.
No.
So e to the negative alpha T.
Yes, and what's alpha?
3, so that's negative 3T.
Yes, what's next?
Then you put in your sine.
Yes.
That's 2T.
Yes.
Plus the angle theta, which is 161.6 degrees.
Yes. All right. I did 2 examples. The rest is up to you. The rest is for you to study. The rest is for you to make sure you know how to do. Okay.
So
Any questions about?
You leave
Excuse me?
You leave in the negative the square root of 40 over 2 like that? You won't go.
No. Evaluate that, yes. Put that in numerical form. Engineers want to see things in numerical form. And the truth of the matter, we should have U of T here as well. Remember we talked about that last class? Whenever you take the inverse Laplace transform, the U of T is implied. All right. One last try. Any further questions about this?
There's chapter 6 in the book, right?
No, I don't think so. Uh,
Or chapter 5.
let me see here. This is chapter 5.
Okay, thanks.
Dr. Cartwright,
Yes.
you said when we do the inverse Laplace, the U of T is applied, correct?
Yeah,
All right. Another question.
but I want you to write it.
So,
What I mean is, as far as Laplace transforms are concerned, time begins at t equals 0. And this makes sure that this function begins at t equals 0.
will we get marked down if we forget the U of T?
Yes.
Okay. One other thing. Y'all started off as G at T equals. Does it matter? Because I don't remember us using G.
No, man, it's g of s, so it has to be g of t.
Oh, that was a G. Oh, all
What
right.
you thought it was?
F.
You think that's a half?
I thought that was
You
a
think
T.
that's a half? Do you think that looks like my app? That app there?
No, I thought that was a T. Yeah. I didn't correct it now.
You mean a small t? Because that ain't big T.
No,
And it can't be a small t because it's a Laplace transform. Laplace transforms are capitalized.
Dr. Cartwright,
Yes.
when we find the roots, will we be required to show the working the quadratic formula?
Well, if you don't show any working, I can't give you part marks.
I mean, because my calculator can do that. I just use the formula. I just use my calculator, double check the answer.
Well, you better be sure then. You better be sure then that you don't put any bad entries then.
So I can do it that way.
You can do it that way, but I'm telling you, I won't be able to give you part marks. So then your answer will be completely right or completely wrong.
Yeah, so if my answer is completely right, then I wouldn't get no points off.
No, not for that.
All right.
For other stuff, yes. All right. All right, now we must move on. What are the roots? Wait a minute. Let me get a better example. Give me a second. What are the roots? What are the roots of the quadratic? Send me the roots by chat. Yes, Mr. Pewchamp, that's right.
Send him an answer right now.
Yes, Mr. Johnson, that's right, but I don't know why you capitalize an S.
Sorry.
One more person, please. All right. Everybody else is lazy or ignorant. Okay. If they are ignorant, then they better learn this material before the final exam. And if they're lazy, well, lazy people don't get anywhere in life. So the roots are -1 and -2. Therefore, the formula I gave you does not apply. The formula I gave you does not apply. The formula I gave you only apply for complex roots.
So if it don't apply, we can leave it like that, or we'll have to do something else.
We're gonna have to do something else, yes. And what's that something else? Rewrite. We can now rewrite a quadratic. We can factorize a quadratic into s+1 and s+2. Since we know the roots, we got the factors. So this quadratic factorizes into that. So if we have s-3 over s+1 times s+2, we can use something called partial fraction expansion. Partial fraction expansion. So this is s minus 3 over a over s plus 1 plus b over s plus 2. So you see what we did there? This is a factor, so it's a factor by itself with unknown constant a. This is a factor, so it's a term by itself. And this is called partial fraction expansion. Partial fraction expansion. And now, how do we find A and B? How do we find A and B? So I'm going to multiply both sides by the denominator. So this side becomes s minus 3 equals A times s plus 1 times s plus 2 over s plus 1 plus b s plus 1 times s plus 2 over s plus 2. So this s plus 1 cancels out s plus 1. This s plus 2 cancels s plus 2. And we're left with s minus 3 equals A times s plus 2 plus b times s plus 1. Now, this is an identity. What's the difference between an identity and an equation? What's the difference between an identity and an equation?
You get identities already. You could like substitute them with stuff like cosine. Like if you notice.
No, this ain't got nothing to do with cosine. You could get identities involving cosine, but that's got nothing to do with this. You could get cosine squared x plus sine squared x equals 1. That's an identity. But what makes this an identity and not an equation?
Because you could quickly identify it?
No. Because it's true for every value of x. No matter what the value of x, this statement is true. Okay. How many values of x is this statement true? How many values of x is this bottom statement true?
All?
No. Man, all our work we just did last class. Huh?
Only 2.
Only 2. Only 2 values. And what are those 2 values called? It's called the roots. This statement here looks like an equation and it's only valid for 2 values of x. This statement here is valid for all values of x. No matter the value of x, this statement is true. So that makes this an identity. So this statement here this is an identity. It is valid for all values of x. Valid for all s values. So let me put that up on another page.
So I don't need to take the screenshot of that one?
You can.
All right, I got it. Thanks.
All right, now let's remember what we're trying to do here. Here we have this Laplace transform. Okay, s minus 3 divided by a quadratic. but that quadratic can be factorized into real parts, into real factors. Not complex factors, real factors. Okay. So because that is true, we can't use the equation I gave you. We're trying to come up with another method, and the method we use is partial fraction expansion. So we're rewriting this ratio in terms of the factors. Are we trying to come up with A and B values? Okay. And then we multiply both sides by the denominator, and we end up with the bottom equation, the bottom identity, which I'm going to repeat. Okay. So S minus 3 equals AS. All right, now, since this is true for all values of S, true for all S values, let S equals -2. So -2 minus 3 equals A minus 2 plus 2 plus B -2 plus 1. So -5 equals, this is 0. 0 minus B. So B equals 5. B equals 5.
I have a question, Dr. Godric.
Yes?
When you was doing identity, was you saying valid for every value of X or for S? I don't know. I might have misheard.
Yeah, man, look at the equation. Do you see an X in that equation?
I see an F. That's why I have to make sure so I can correct my notes. Yeah. Thank you.
But if we wrote this as X minus 3 equals AX plus 2 plus B X plus 1, is that correct? Yes, it's correct. Then this is valid. Then this is valid for X values, all X values. But our variable is not X. Our variable is S. I don't know why y'all don't have the hang of algebra yet.
I have a question, Dr. Godric.
Go ahead.
So I see you said S equals -2.
Yes.
And since it's true for all, I could use any S values and get the same answer.
Well, not as quickly.
Oh.
Did you see that my choice of S equals -2?
Yeah, I see you choose that so your A could cancel out.
Made A disappear?
Yeah, I see that.
Exactly. And which value?
You have to plug in.
You could use -1.
I'm going to use -1. Miss Butchap, you have the hang of this. Let S equals -1. Then we have -1 minus 3 equals A, -1 plus 2 plus B, -1 plus 1. Now you see we made B disappear. We made B disappear. So this is now -4 equals A times 1, or A equals -4. Notice this is a root. This is a root. So now what we got? Now we got S minus 3 divided by S plus 1 times S plus 2 equals A, -4, S plus 1 plus B, 5 over S plus 2. That's the identity. That's the identity we come up with. And now let's check to see if that's correct. So s plus 1 times s plus 2. That goes how many times? So that's negative 4 times s plus 2. That goes 5 times s plus 1. So that's negative 4s, negative 8, plus 5s plus 5 over s plus 1 times s plus 2. Okay. So that is s, okay, minus 3 over s plus 1 times s plus 2. So that's correct. That checks. Okay. So,
Could you go back 1 second? Thank you.
okay. So now I got here s minus 3 over s plus 1 is the inverse Laplace of negative 4 over s plus 1 plus 5 over s plus 2. Okay. So this is the inverse Laplace of negative 4 over s plus 1 plus inverse Laplace of 5 over s plus 2. So that's negative 4 inverse Laplace of 1 over s plus 1 plus 5 inverse Laplace of 1 over s plus 2. And now from the table, so this is negative 4. From the table, what is this? From the table, what is that? Folks, I told you all to memorize that table. Excuse me?
E to the negative alpha t.
Oh, what's about the alpha?
Alpha is 1.
So e to the negative 2. E to the negative t. Right. What's this one?
E to the negative 2t.
Of course, all of that is being multiplied by u of t. Now, so this is another method. This is a partial fraction expansion method. We use this with quadratics, that have real roots, real and unequal roots.
There's a question like this on the final, the past final exam.
Excuse me?
No, I'm asking a question like this is on the past final exam you sent to.
I don't know. Why does that matter? Now listen, folks, I hope you all don't misinterpret this final exam. This final exam does not mean I have to give you a question like these, like identical to these on the final exam. That's not what that is for.
Now I wanted to see the structure of a question like this.
Well, the question, a question could simply be, here's x of s equals to this. Tell me what x of t is. The question could be, here's the question. If x of s
You freeze.
Yeah, I think he got out.
Next 2-3 weeks. Good.
Oh, guys, don't forget registration start today. Online registration.
Seniors, juniors on the 10th, right?
Yeah.
You. Oh, all right then, yeah. Cause I take one picture of you, be survival guide to make sure.
Okay, I'm back. Miss Beauchamp, did I answer your question?
Right when you started writing, you got freeze. I see it now.
Okay. Oh, by the way, this may come about by solving a circuit. So it may not be. I may tell you find the output voltage of a circuit, and this is what you'll have to do to find the output voltage. This would be the output voltage. But we're getting ahead of ourselves. That's chapter 6. Now, I want to go back to this and show you shorthand notation for what we do. Here's what we do. A equals, see this is S plus 1? We cover S plus 1. So that leaves us with S minus 3 over S plus 2. And then we evaluate at the root of this, S equals negative 1. So it'd be negative 1 minus 3 over negative 1 plus 2, which would be negative 4 over 1, which is negative 4, which is exactly what we got the long way. And here's B now. Here's B. B is coefficient of S plus 2. So we hide S plus 2, and we're left with S minus 3 over S plus 1. Then we evaluate at this root. Which is what we got before.
And you make us go on a long way.
Yeah, man. I've shown you the logic of the long way. If I just gave you this formula, you would have said to me, where did that formula come from? And that formula is just a shorthand notation of what we did the long way. And when I finish with these Laplace transforms and inverse Laplace transforms, I got a secret to tell y'all.
Man, you can tell us now.
No, it's a secret. You have to learn what we're going through now. Because it's the basics of understanding. These days, anyway, I won't go there. Let me give you one more to do. Can we factorize that? All right. Find the roots of this then. Send me the roots in chat.
Hey, hey, what was that question, that equation we had on the screen, though?
It was s plus 2 over s squared plus 5s plus 4. You wanted us to find the roots.
Thanks.
Okay, I'm back. I'm having problems today. You're supposed to send me the roots. Send me the roots in the chat. Yeah, Mr. Buchamp, that's right. But I guess it's right because you're using your calculator properly.
Ain't allow me to send, but could I tell you the answer? Or the roots?
Yeah, go ahead.
Pardon me?
Yes, go ahead.
S equals -4 and S equals -1.
Okay, good. So that means the factors are find me A. Send me answers in chat.
Any of y'all get the question?
Yeah. That's the same equation. A and B. A over S.
You breaking up, boy.
You get me?
I get you now.
A over S plus 1 plus B over S plus 4.
Okay,
No, wait.
thanks.
What you say it was? What the start off equation was after the is S plus 2 over S plus 1 and S plus 4, right?
S plus 2 over S plus 4, close bracket, S plus 1.
I put the 4 to the front.
That's just why I write it. I don't really see what he write.
Yeah, I see that on my screenshot that. Oh boy. All right.
Anybody has an A value yet?
I send it to the chart right now.
I have one answer. I don't know if it's right. All right. Let's do it. So A equals I to S plus 1, S plus 2 over S plus 4. Evaluate at S equals -1. So it's -1 plus 2 over -1 plus 4. So it's 1 divided by 3. A equals third. I think at least 2 people got that right. B, right? B hide the S plus 4. So it's S plus 2 divided by S plus 1. Evaluate at S equals -4. So it's -4 plus 2 plus -4 plus 1 equals -2 over -3 equals 2/3. So this here is a third. It's a third over 1 plus S1 S plus 1 plus 2/3 over 1 plus S4. And if I call this Y of S, then Y of T will be a third e to the minus T plus 2/3 e to the minus 4t, all that multiplied by u of t. Any questions about that?
Hey, Dr. Cartwright, would it matter if I just happen to have like the A and B mixed up? Actually,
Absolutely, it matter.
okay. It still would have been the same answer.
No, it wouldn't have been the same function. If you had A and B mixed up, then this would be 2/3 and that'd be a third. Oh, it's like the same thing.
No, what I did was instead of putting the open bracket, okay, the equation is S plus 2 over S plus open bracket S plus 1 close bracket open bracket S plus 4. Instead of putting the S plus 1 first, I put the S plus 4 first, and then putting the S plus 1.
Oh, okay. So all you're saying to me is you interchange.
Yes, I just changed the A and B. Yeah. But I still turned it
Yeah,
around.
no, that's fine. That'd be fine.
Okay.
Okay. Yeah, that's fine. I mean, you could have called, in other words, you could call this A over S plus 4 plus B over S plus 1. That's fine. But then your A and B values would be different from mine. But when you come back to actually plugging these in, though, when you come back to substituting the A values and B values, then you would have to get this. That would have to be the same.
Yes, sir.
Okay. Any other questions or comments?
Could I see page 8, please? All right, thanks.
All right, there are lots of questions in the book. Lots of questions in the book. Next class, we're going to have to move on. So if you don't study this material, you will not learn this material. It's as simple as that.
We have a lot more homework to go.
Yeah, man, cheapest you drop homework on this.
We got more homework to go. Any other questions or comments?
Will you be making homework on this topic?
I'm not promising that. Because what we're doing right now is just preparation for solving circuits. The emphasis of this class is solving circuits. The emphasis of this class is not math.
Right.
Dr. Cartwright, I have a question.
But unfortunately, you need math to be able to solve the circuit. Yes, go ahead.
You're my advisor. So do Zoom meetings, or I can just email you.
If I'm your advisor, send me your complete transcript.
I don't know what that is per se, but yes,
You don't know what a transcript is? Well, how do you know I'm your advisor? I'm just curious. How do you know I'm your advisor?
When I log into the Banner thing, the student space, I really can't remember the name, but it tells me.
All right. I'll check to see if I'm legally attached to you. I'll check to see if that's true. And if it is, then I should be able to get your transcript. But if it isn't, then either I'm not I'm not your advisor, somebody else is. Anyway, I'll check on it. I'll get back to you.
Thank you.
All righty. That's Johnson, right?
Yes, sir.
Okay, good. Just making sure. Anybody else? All right, have a good day.